All right, let's dive right into this explainer with a completely absurd but totally fascinating thought experiment to uncover some amazing astrophysics. Have you ever wondered what would happen if our comforting, glowing moon suddenly became our biggest threat? Today, we're exploring the extreme physics of celestial impacts. We are going to look at everything from wild hypothetical scenarios to the incredibly violent origins of our own Earth, and finally, how experts are actively preparing for real threats from space today.
So, to get us started, I want you to picture a scenario straight out of a viral Reddit prompt. What if the moon slowly, almost imperceptibly, started creeping toward Earth? We're not talking about a high speed, fiery comet collision like you see in the movies. We're talking about an extremely slow speed approach. Would life on Earth be able to survive simply because the impact itself was just, taking its time? It sounds like a fun sci fi premise, but the actual physics behind what would happen are incredibly illuminating and honestly, a little bit horrifying.
You know, it's actually remarkably easy to get the physics of this completely wrong. Take this authentic 1937 Life magazine illustration, for example. It showed a hypothetical scenario where the moon gets closer to Earth, and the artwork depicts people literally floating off the ground up toward the moon. Astrophysicist Neil deGrasse Tyson hilariously debunked this. He pointed out that Earth's gravity is significantly stronger than the moon's, so even if the moon were looming massive in our sky, right inside our atmosphere, we wouldn't just float away like a bunch of balloons. We'd stay firmly planted right here on the ground.
Okay, so if we aren't going to magically float away, what actually happens when it finally bumps into us at a snail's pace? Well, a user in that exact same Reddit discussion offered a pretty perfect analogy. Imagine two massive freight trains colliding at just 5 miles per hour. 5 miles per hour sounds slow, right? But all that intense weight and massive bulk wants to keep moving forward. That raw momentum causes serious structural damage to the trains and violently jostles everyone inside. The moon has a truly incomprehensible amount of mass, so a slow-moving impact would still transfer a devastating amount of energy. It would wreak absolute havoc on Earth's crust. But here's the real twist. The moon would never actually touch the surface of the Earth intact. No way.
Right, so here is the major plot twist. The crucial point here is something called the Roche limit. Discovered by the French astronomer Edouard Roche, this is a strict mathematical boundary based on Newton's laws of gravity. Basically, if a celestial body, like our moon, which is held together by its own gravity, gets too close to a much more massive body, like Earth, well, the tidal forces of the larger planet become stronger than the smaller body's own self-gravity. So long before the moon could ever slowly bump into our oceans or continents, Earth's gravity would literally tear it to pieces. Let's actually look at the math behind how aggressive that tearing process is, because it's wild. As the moon gets closer, the destructive tidal forces don't just increase at a steady, linear rate. Oh no, they increase by the inverse cube of the distance. To put that into perspective for a second, if the distance between Earth and the moon is cut to a third, the destructive force doesn't just triple, it increases by 3 cubed. That means the tidal forces trying to rip the moon apart would suddenly be 27 times stronger. So ultimately, the moon would just shatter. And instead of a single slow-moving sphere, Earth would suddenly be surrounded by a massive, completely lethal ring of lunar debris. If you're a fan of sci-fi, you might actually recognize this from Neil Stephenson's book, Seven Eves. In that story, characters on the International Space Station are forced to watch as a shattered moon slowly turns into a swarm of meteorites that relentlessly bombard and completely incinerate the surface of the Earth. So it turns out surviving a slow-speed lunar approach isn't about bracing for a gentle bump. It's about trying to survive a fiery bombardment from our newly formed rings. And the coolest part? We don't even have to rely on thought experiments or sci-fi to see this in action, because we can look right out into our own solar system. The case for Earth getting a lethal lunar ring perfectly mirrors new astronomical evidence regarding Saturn. Recent studies actually suggest that Saturn's iconic rings are, in fact, a young, shattered moon. This scenario beautifully explains why Saturn's rings look so youthful compared to the age of the giant planet itself. It is literally the Roche limit in action, painted right across the cosmos. But hey, let's bring the focus back home to Earth for a second, because our planet and our moon actually do share a history of a massive, incredibly violent celestial collision. We didn't always have a moon. The prevailing scientific consensus today is that the moon was formed by a giant impact event between a very young Earth and a Mars-sized body billions of years ago. It's a pretty stark reminder that the serene, predictable orbits we look up at today were actually born out of absolute cosmic chaos. And this is where it gets crazy. Recent NASA simulations gave us a really stark, high-contrast look at this exact impact. For a long time, scientists didn't fully account for the complete energy budget of this massive event. But recent high-angular momentum models show that the post-impact Earth was left as a rapidly rotating, supercritical magma ocean. We're literally talking about tens of percent of the silicate mantle being transformed into supercritical fluid or vapor. And perhaps the absolute most staggering detail from these NASA simulations, the moon didn't take centuries to slowly coalesce from a debris ring. It may have formed in mere hours. Just hours.
Now, while we thankfully don't have to worry about our own moon turning into a lethal ring of fire anytime soon, near-Earth asteroids, yeah, those are a very real, highly documented threat today. We don't have to look back billions of years to see the very real impact of space rocks. And because it's a legitimate threat, the global scientific community is actively working on how to protect our planet so we don't end up going the way of the dinosaurs or living in some hypothetical, post-apocalyptic sci-fi novel.
And this brings us exactly to the real-world efforts that were just discussed at the 2025 IAA Planetary Defense Conference. This huge gathering brought together global experts to discuss literally everything, from discovering imminent impactors to plotting out complex asteroid deflection strategies. But, one of the most critical takeaways wasn't just about rockets and physics. It was actually about communication. They highlighted the urgent need for effective public messaging. Because top-down official messaging might not resonate with everyone, they really emphasized leveraging localized, trusted voices. Think traditional community leaders and even social media influencers. They need these voices to prevent the rapid spread of misinformation during a potential crisis. And honestly, this whole collaborative mindset is perfectly reflected by the very people working day in and day out to keep us safe. When attendees at the 2025 conference were polled on what they should do more of next time around, over 21% explicitly wanted more international collaboration workshops. This was the #1 most requested feature. I think it highlights a really profound understanding that defending Earth from a celestial impact absolutely cannot be the job of just one nation or one space agency. It's going to require a unified global response. So, from wild Reddit thought experiments about a falling moon to the actual violent origins of our magma-covered Earth, and finally, to the conference rooms where global experts are plotting to deflect real asteroids, the physics of our universe are both deeply awe-inspiring and incredibly unforgiving. And it leaves us with one critical question to ponder. As the cosmos continues its chaotic dance, are we, as a unified global society, truly prepared for the next celestial threat? I really hope this explainer has given you a whole new perspective on our place in the solar system. Don't forget to like, comment, and subscribe.